Hello again, everyone. Welcome back to CCCS121, Programming 2. I learned that we had some audio problems with the last video, so I'm going to give you a quick recap of what I talked about. Fortunately, much of it must not have been news for you. Um, so we talked a little bit. That video was about the use of subclasses as a way to add new properties, new methods, new functionality to existing classes that you already have, which we then make our superclass. One important, so I talked about three different things basically, as the concept of overloading a method, something you've already seen. So, for example, we've had classes for which we had multiple constructor methods, like the one in this slide. Uh, these different constructor methods all had the same name. So let's say for a class called circle, all of these constructors would have the name circle for the constructors, of course. But they would differ in the number of arguments that they would take, or the types of arguments that they would take. The list of arguments that a method takes, any method, not just the constructor, but any method, is called the signature or toki of a method. Okay. So if you have a method, if you have multiple methods with the same name in the same class, that is called method overloading. Actually, they don't even have to be in the same class. That you can even be getting one method from a superclass. You could be inheriting it from there, and you could have another method in the subclass. And all they would differ in is the argument the signature that they have. So here on the right side, for example, we have a class B, a superclass B. We have a subclass A, which extends B. B has a method P, which takes a double. A also has a method P, but this one takes an integer. So same method name, P, but different argument types. This one takes double, this one takes an integer. Of course, this method could be doing something else. This one could have completely different code inside. This is an example of method overloading. Then we have method overriding. Slight difference over here. So again, we always have two classes which have a superclass subclass relationship. So again, we have class B, which is a superclass. We have a class A, which is a subclass of B, and both of them have a method called P. Both of them, and both of them take an argument of type double. So when you call the method P, give it an argument of type double for an object of class A, this method will be called. Because this method is kind of overwriting or overriding, actually. That's the right term for that. It's overriding the method that is defined in class B up here. So the example that I did in the last video lecture is basically a more elaborate example that shows the difference between overriding and overloading. One more important thing that I talked about is the object class in Java, in the Java API. So we've seen that classes can have superclass, subclass relationships. As it turns out, whenever you make a class of your own, if you don't make it a subclass of any class, your class automatically becomes a subclass of the object class in Java. So in that sense, every class that you've ever worked with in Java is a subclass of some other class except the object class. The object class sits at the very top. Yeah, so and flowing from that is then the idea of that toString method, why is it that we can call the toString method for any class without even writing it at times? And I also demonstrated that in the last video. The reason is that the toString method is actually a method of the object class, which sits at the very top in the Java API. When you just call the toString method on any object, even on any class, even a class that for which you did not make or define a toString method, what happens is the toString method of the object class here at the very top, that is called, unless of course you decide to override that toString method, which is always advisable, as I've mentioned before, and which we should always do to get a more useful kind of output. So in the example that I showed you in the last video lecture, if you just call the toString method, if you don't override it, if you don't make your own, the toString method will return the package name dot the class name at, and then what is to us at least a random number after that, a random looking number, not useful at all. No, this number has no meaning for us. That's why we usually like to print out something more useful in the toString method, and we should always do that. Okay, so the main topic for today is a concept called polymorphism, or in Arabic, I think the closest that I could get in terms of translation is تعدد الأشكال, which means something like many faces from Latin. And so let me begin by demonstrating polymorphism. If nothing else, if you understood what we've talked about in this course up to this point, and if you can understand, once you understand the meaning of the concept of polymorphism and how it can make our lives easy as programmers in certain situations, if you understand that, I think that will be the gist of object-oriented programming. Okay, so let me switch over and let's do this small example. So I'm going to do 2 examples today, so I have a little less time than usual. I'll be doing some copy pasting of some very straightforward code. So I begin by, and I'll do this all in one file because this is such a small example. So I'm adding a class person which extends object. I don't have to write that. Like I said, if you don't type extends object, the Java will insert it for you. Okay. So we have at the top, we have, so to speak, we have a class person, and what we do is we override its toString method to one that returns the string person, the name of the class, nothing else. And then we create a subclass of person, and we call this one student. So class student extends person, and we override the toString method that we are inheriting from person, and this one is going to print out student because this is the student class, as you can see. And then we have another subclass of student, and this one is graduate student. Graduate student extends student, and this one okay, let me actually just kind of be consistent. Let me just override its toString method, and this one returns the string graduate student. Okay. Now let me go up to the main class over here, and Before I go into the main method, let me add another method over here. Public static void, and this method is m, and let me, yeah, here's what I wanted to do: system.out.println, and all I want this method to do is receive an object over here, call that object's toString method, and print out whatever the toString method gets. But I want to use this single method over here for not only the person object, not only for objects of type student, or only for graduate student, but I want this one method, I want it to work for all of these classes. This is where we, now thing to remember is graduate student is a special type of student. Student is a special type of person. Person is a special type of object. So in a sense, a graduate student, an object of type of class graduate student is also an object of type student. And because student is a subclass of person, that object is also an object of type of class person. And because person is a subclass of object, my graduate student object will also be an object of class object with a capital O. This is where we are now going to demonstrate polymorphism. I'm going to specify as the type of argument for this method m, the class object. So x over here should belong to class object. Now, object is a superclass of person, which means any object of type person is also an object. And because every student is also a person, and person is an object, every student also qualifies as an object, and so does every graduate student also qualifies as an object. So, due to polymorphism, I am able to use this method, which will accept any argument of type object. I can give it an object, sure, but I can also give it something more. I can pass it any object of a subclass of this class, of Java's class object with a capital O. So I could pass over here a graduate student object. So what I'm doing over here is I'm making a graduate student object, and I'm not even giving it a reference name or anything, because I'm just passing it straight to method m. And guess what? I'll do this with the other classes as well. I also have person over here. And you know what? I think I could even do this with object. There you go. And once I pass, okay, do these one by one, not to overwhelm you guys. Okay, so let's just try it with, let's create a graduate student object, pass it to m, and inside of m it will be, which takes anything of type object or derived from object, any subclass of object, and it calls its toString method. There you go, graduate student. And like I said, I can do the same with student. person. You can even do it with an actual object of type object. And remember, we did not override or overload the toString method of object, so this is what Java usually gives you back. Okay, so you can see that instead of having to make 3 different methods, one that takes an object of type graduate student, one that takes an object of type student, a separate one that takes an object as argument of type person, we can use a single method and it will work for all of these. Now we have another example of the use of polymorphism. So this takes us back to the example we did in the video lecture for week 9.2. So we had, just to remind you, we had a superclass called geometric object, which had subclasses circle and rectangle, and in class I asked you to add a third subclass called triangle. We're interested over here in basically doing something similar to what we just did with this method m. Take note of these 2 methods of the geometric object superclass, getColor and getDateCreated. Okay. Now these are 2 methods. They're public, as you can see from the plus sign in front of them. And because geometric object is a superclass of circle and rectangle, these methods, like all of the other public methods, are inherited by circle and rectangle, which means I am allowed to call the getColor method of a circle object. I am also allowed to call the getDateCreated method for a circle or rectangle object, because these methods are inherited by these 2 subclasses. So what I want to do is I want to basically take the example that I have and I want to extend the main method, the main class, class 9.2, week 9_2, and what I want to do is I want to add a method to it. I want to add a method called displayObject, and what it should do is it should basically take any type of geometric object, rectangle, circle, triangle, anything else that you make a subclass of geometric object, and it should call its getDateCreated, print out its creation date and its color. Now remember, these 2 methods, getDateCreated and getColor, are inherited from geometric object, but the actual object that I pass it, the geometric object I pass over here, can be a circle or a rectangle. So instead of making separate methods of displayObject for every type of subclass, I can again make use of the concept of polymorphism, and for this method I can specify that, you know what, take any geometric object, any object of type geometric object, or any subclass of it. So the concept is exactly the same that we just saw. Since it's a simple modification of the example that we already did, I'm just going to copy paste this. I'm going to go to our week 9.2. Okay, we're done with this. Going to go back to week 9.2, geometric object. Actually, this is the main class, and going to add this. Going to add this method over here. fix the indentation like you should too. Okay, so we now have a new method called displayObject, which will take any geometric object and it'll call getDateCreated and getColor method. But so let me make use of that up here. System.out.println, and let's take a look. So I create a circle up here and a rectangle, circ1, rect1. So first I'm going to pass it circ1, and so in addition to everything else up here, let me put in a new line in here, so this is separate from all the other stuff we're printing out. Okay, there you go. Okay, circle blah blah blah, white created on color white or false. See if we can go back in here, maybe created on date dot. Okay, let me run this one more time. Yeah, color white and filled false. There you go. Let me do another thing. Let me also call this for the rectangle object that we've created. And see, oh, I'm sorry, this is just a call to the toString method. What I want to do is, yeah, I'm going to call the displayObject method for these. Sorry. Okay, so I'm going to call the displayObject methods for circ1 and rect1. Yeah, that's what I wanted to do. And run this. There you go. Created on November 12, 10, 15. Right now, color is white, and for the other one, created on blah blah, color is purple. And is it default color for circle? I think we kept that at white with a no arc constructor, and for the other one we set it to, for the rectangle we set it to purple right here. But the thing that we're interested in seeing over here is that we have one method, displayObject, and it is able to accept a circle object, the one we created up here, and it is the same method is also able to accept a rectangle object created up here. But we did not have to make, we could have made two different methods for that. It would have been fine, but as soon as, let's say, we add a rectangle subclass to geometric object, that would mean I would have to create a third version of the displayObject method. But by making use of polymorphism, we're now able to keep a single method, and it will work for any geometric object or for any object of any subclass of geometric object. And that's the beauty of polymorphism. Now, sometimes it's possible that you have different versions of the same method in multiple classes. So let's say we have a whole chain, a hierarchy of classes. So at the very top, let's say we have the object class Cn, and a subclass of that is Cn-1 and Cn-2, and all the way down to C2, and then the most specialized class is C1. And let's say we create an object, let's call it obj, um, of class, let's see, let's say we create an object obj of class C1, okay, and let's say we call obj.p. We're trying to call the method p on an object, on an instance obj. Now, if obj is of an object, an instance of class C1, the JVM will start looking for the p method in class C1. If it doesn't find one, it will go to the superclass, to its superclass C2. And if it finds one, fine, it'll execute that. But if it doesn't find one, it'll move on to C3. If it finds one, fine. If it doesn't, it moves on. And it'll keep searching all the way up to the object class, Cn in this case. But if there are multiple implementations of method p, it will run the first one that it finds, the first one, starting its search from the class of which the most specialized class. Okay. This way of programming of that we actually just demonstrated twice, of writing a single method able to accept kind of a more generic superclass, and using that one method to for use for more specialized subclasses, or for subclasses. This is also called generic programming. Okay. One more thing I want to talk about is casting. There's just 3 lines of code. I want you to try these on your own. So casting or sub is basically to convert, we've already done this with variables. It's basically used to convert one type of variable into another. Now, sometimes you can cast from one type of variable into another type, but you cannot cast back. And you can use casting not just for variables, but we can also use casting for objects. We can use them for objects of classes that are related to each other, that are linked through superclass-subclass relationships. So let's say we have a class student, and we create an object of type student. We can do something like this. So you create an object of type student, but you assign, usually we assign it to a reference, and that reference will be of the same type as the class, or as the type of the object. So usually we would write student over here, student O equal to new student. But we can actually also use a reference to any class that is a superclass in the hierarchy of student. So this is perfectly all right to do it this way. So this is basically what we call implicit casting. We ourselves are deciding that we're casting the student object to a reference of one of its superclasses. In this case, the object class. But if we want to cast back this object reference O, or if you want to copy that to a student, to a student object like this, you would get a compiler error. Now, this doesn't mean that there's no way out of this. If you know that this reference to an object is actually a student, you can say so. And you can do something, again, another type of explicit casting like this over here. You can specify that O is actually of type student, and please, I don't need to say please, but you can declare another reference of type student, and then you can assign the reference of O. You can copy that to another reference of type student B, like this. Try it out. Okay, that's another example between fruits, apple, orange. An apple is a fruit, an orange is a fruit, but not every fruit is an apple. Not every fruit is an orange. That's kind of the shorthand idea behind this. Actually, you can try this out with the first example that I did today. Try it out. Try out casting between student, graduate student, person. See how that works out. There's really not much more to it. So yeah, that is it. At 31 minutes. I'll see you all tomorrow.